Hey guys, welcome back to AlgoYogi. We are doing two pointers series, and the next problem in the list is merge sorted array. Let's go to LeetCode and go through the description. So it says you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. So that means increasing order, but not strictly increasing. It's like some numbers can be equal. And two integers m and n, they represent the length of nums1 and nums2. Now we're going to merge nums1 and nums2 into a single sorted non-decreasing array, and we're going to take care of some things. That means this extra information just says that nums1 has the length equal to m plus n, and whatever m's value is after that, everything is just 0, not 0, 0. So as you can see over here, I think let me just switch the view here. So nums1's length is basically, here it's 6, but m is 3. So that means nums1 only has these 3 elements. Nums2 has 3 elements, all of it. Now we're gonna merge this one and this one into one single array, and that length will be equal to length of nums1, because they have already accommodated the length of this as appending 0 length array next to nums1. So basically this is nums1 and this is that extra length that will be appended of nums2, so that when they are sorted, then it becomes basically of length m plus n. Okay, so now how are we going to merge it? What I think is, since we are not allowed to use any extra memory, it's not just we create a separate nums or like some result array, and then you basically iterating over both of these, and then whatever is a smaller value then you choose. So and you're choosing basically like this, and then you are returning this array. So this is a new array. We could do it like that, but we're not returning anything. What we really want to do is modify nums1 so that it accommodates all the nums2 values, and in the end it's just nums1 containing nums2 value and nums1 value, but both are in sorted order. Okay, so if I say how are we going to fill it? So I think it's going to be difficult if you are going from front to the back, because it's increasing values, and you will have to push all the values, all these values. If you're basically trying to insert something over here, then you got to push all these values to later, so later indexes, I meant. What we can really do is, how about we start our basically pointers, point 2 and point 1, point 1 at the m-1 and n-1 index, and then we check which one is the bigger. Whatever is the biggest, then we maintain this as ith pointer, and then we put that value over here. So by the time we'll come to the front of both of these arrays, then by then making this choice, we must have filled this nums1 from back to the front, all in basically non-decreasing order. Yeah, okay, and then you can see in this example 2 as well, we can do the same thing. So right now nums2 is empty, and we got to make sure that when nums2 is empty, so that means this pointer p2 will be, p2 is less than 0. Okay, so we will calculate p1 and p2. P1 and p2 will be basically, so p2 will be n minus 1 and m minus 1, so that we are, because index starts at 0, so it will always be basically m minus 1 and n minus 1. We need to start that. Okay, so let's go and code it up. This is gonna be an easy solution. So let me change the view here. Okay, let's write down our solution. And it's going to be a big of n plus m time complexity, right? Or you can say the length of nums1, not the number of integers, nums1, the length of the array. Okay, so let's say p1 and p2, they're going to be, p1 is m minus 1 and p2 is n minus 1. So these are the indexes that are starting basically in nums1, wherever nums1 basically all the integers of nums1 remaining are 0. That will be basically once we have merged both those arrays, and then it will take that place. All right, so what I was thinking, I don't know. Okay, this is really stupid, whatever is in the, anyway, let's write down. Now we're gonna iterate for I in range, and that will be basically m plus n, or we can say length of nums1, and we are basically starting from the back, and we're gonna come until -1, but because it ignores whatever range you give the last thing, then it's gonna come only up to 0th index, and then the direction. Now what we do is, if nums1 p1 is basically greater than, or we can say equal to, you know, like I would say, like if nums1 p1 basically in the end, if it is greater than nums2 p2, that means we will have to use the nums1 value at p1 point. So I'll say my nums1 ith, because we're starting at the back right now, they must be all zeros. We want to assign p1's nums1's p1 indexes value. All right, otherwise else you do something else. What is that? You assign it nums2 p2. Okay, but let's make sure that we are incrementing these, sorry, not incrementing, decrementing. They're already starting in the back. Okay, so that's it. Now let's make a check if num2's values are exhausted. That means num1 values already sorted, were already in the place, so we don't have to do anything, we just break out. So if p2 is let's say lesser than 0, that means it has reduced down to 0. That means we break from this loop, and we don't have to do anything anymore because we have just exhausted all the nums2 values, and which we were pushing at right places in nums1. Okay, and in order to check this, I think we should have a check that if p2 is greater than or equal to 0. Okay, and it's also, the value is also bigger than nums2. Otherwise we do this, and if p2 ever gets exhausted, basically all the elements of nums2 are used, that means it breaks out. And I think that's it. Let me zoom out so that we can run it on examples. All right, passes the examples. Let me submit. It's an easy problem. Okay, I think I have something over here, and that's just p1, p2, decrementing nums1, p2, p1, if nums1, nums2, p2. What's this? It should be not 2, 2. Okay. I think that's happening because this made the right choice, but when P2 was exhausted, then it was supposed to use P1. So it's not P2, it's P1 that should be greater than, because we already checked it. All right, there is no way this can go wrong here now. Okay, let's write the time complexity. Time complexity. I just ran 5 miles and I'm having this runner's high. I don't know why I'm telling it. So exhausted. So big of n plus m, which is also the length of nums1, and space complexity is big of 1, so that's constant because we're not utilizing any extra space. All right, so let's go to AlgoYogi, mark this solved, and see you guys in the next problem.